So in this second video, we're going to have a look at how we substitute numbers into expressions for Kc. So have a look at your worksheet and we're going to do the first problem together. Here you can see we're looking at this equilibrium where 2 moles of sulfur dioxide reacts with oxygen to produce sulfur trioxide, and it's a reversible reaction, so it can reach equilibrium if it's left. This reaction is called the contact process, and it is used as part of the multi-steps required to make sulfuric acid. So, according to the question, we have the concentrations of the 3 chemicals at equilibrium. There's the concentration of sulfur dioxide at 0.230 moles per decimetre cubed, and there's the concentrations of the other 2. So I've just got those numbers from the question. I'm now going to solve the problem in 2 steps. So to solve this problem, the first thing we're going to do is to write the expression for Kc. So here is the equilibrium. Kc equals the concentration of the product, SO3, squared, because of the 2, divided by the concentration of the reactants, concentration of SO2, squared, because of the 2, multiplied by the concentration of O2, but that's just to the power of 1. Now we can substitute the numbers into this expression. So Kc equals the concentration of SO3. So if you look back at the numbers in the question, you'll see that the concentration of SO3 was 0.920 squared, divided by the concentration of SO2 at 0.230 squared, times the concentration of oxygen, 1.370. So therefore the concentration of Kc, now I can't do this in my head, so I'm going to use a calculator, and we're going to go 0.92 squared equals at, divided by 0.23 squared equals at, divided by 1.37 equals at. So the answer is 11.7. Now units. This is moles, decimeters to the minus 3 squared, divided by moles, decimeters to the minus 3 squared. Ooh, they're going to cancel out. Very useful. Moles, decimeters to the minus 3 from the oxygen. So if these 2 cancel out, this becomes 1 divided by moles dm to the minus 3, or mole to the minus 1 dm to the 3. Now can you see that this is quite a big number? It's much bigger than 1. So the equilibrium, if we look back at the equilibrium, there'll be quite a lot of SO3 in the mixture and not very much of these other 2. So the number for Kc tells us about what's actually happening in the chemical flask.